A tree diagram is basically a visual way to write out a sample space and calculate probabilities. For instance, we could draw a tree diagram for flipping a coin 3 times. So the first flip could be heads or tails. So we branch these off from one another. And at the end of these branches, we can put an H or a T for heads or tails. Now we can address the second flip, which again can only be a head or a tail, 2 possibilities. So from both the H and the T, we can put in 2 branches to represent the possibilities. If the first flip resulted in a head, the second flip could be a head or a tail. So at the end of the branches from the first flip being a head, we again put an H or a T. And we do the same for the bottom portion of the diagram. If the first flip was a tail, second flip could be a head or a tail. So an H and a T at the end of the branches from the first flip being a tail. So now after 2 flips, we have 4 different possible paths, so to speak. And for the third flip, there again are only 2 possibilities, heads or tails. So from each of these, we can draw in 2 branches outwards. And at the end of the branches in the top path, head on flip 1 and head on flip 2, we can address flip number 3. Again, there can only be a head or a tail for flip 3, so we write in an H and a T at the end of these branches. And we can write these possibilities in for the end of the branches for the other 3 paths, H or T. So after doing all of this, we have a total of 8 possible paths or outcomes. And we can write those in on the right side of the diagram to make it a bit clearer. So at the end of path 1, we could have gotten a head on flip 1, a head on flip 2, and a head on flip 3. So HHH for the outcome. Next we have a head on flip 1, head on flip 2, and a tail on flip 3. So HHT. And you would go through the rest of the paths or branches and fill in the possible outcomes as you see on the screen. Tree diagrams also make it somewhat easy to calculate probabilities. Starting with coin flip number 1, we can get a head or a tail. So there's a 50% probability of either, which is 0.5, or fractionally 1 over 2. So we can write that in near the branch going to H for coin flip number 1, and do the same for the branch going to T for coin flip number 1. And we can actually write in 0.5 for each branch in the diagram, because there's always a 50% probability of being a head or a tail. Now we can calculate the probabilities for the outcomes. So let's look at flip 1 being a tail, flip 2 being a head, and flip 3 being a tail. If we go through our branches, we have a 0.5 probability flip 1 is a tail, then a 0.5 probability flip 2 is a head, and a 0.5 probability that flip 3 is a tail. To calculate the probability of tail, head, tail, we multiply the probabilities. So 0.5 times 0.5 times 0.5, which equals 0.125 or 12.5%. We can do this fractionally as well. 1 over 2 times 1 over 2 times 1 over 2 equals 1 over 8, which again equals 0.125. Drawing a picture in many cases makes things clear. And here is an example of a tree diagram kind of showing this. Let's say you want to know the probability that your favorite hockey team is going to win its next 2 games. You do some statistical wizardry and come up with your own probabilities for their next 2 games. On the screen is a tree diagram for the 2 games and the possible outcomes. For game 1, they could win, lose, or tie. Your calculations give them a probability of 58% to win, 26% to lose, and 16% of tying. Regardless of the results of game 1, your calculations for game 2 give them a 72% probability to win, 24% probability of losing, and a 4% probability of tying. To keep the video short, I've written in all the probabilities on all of the branches. Going down the branch to win game 1 and win game 2, we have 0.58 times 0.72, which equals 0.418, or a 41.8% probability to win the back-to-back games. On the right, I've listed the 9 possible outcomes, and by totaling all of the probabilities, we see the lowest probability is a tie and a tie at less than 1%. And the highest probability is actually to win game 1 and win game 2. But you can see this gives you a nice visual to look at and understand, rather than just numbers, which can oftentimes make it easy to get lost and confused. Alright my friends, hopefully this video helped you out. I do have more videos right there for you. Till next time, I am out of here.